So let's take a look at how we can use Jenkins-X with machine learning in production environments. So when we're dealing with machine learning projects, we have multiple stages that we need to go through in order to get to a final product. So initially you need a large amount of training data, which you're then going to use to train one or more specific types of machine learning model, which you then want to be able to deploy wrapped as microservices within your production environment, so that other aspects of your application can utilize those as part of a defined distributed whole. The challenge is that we actually have to maintain the life cycle of all of our components. So our machine learning training process depends on a known set of training data, and our deployed services depend upon a known version of a particular trained model. So to bring this all together in a production environment, we have to be able to control the life cycle of our data. We have to control the life cycle of our trained models, and we have to control the life cycle of any production services that are consuming those models. We may also have very large numbers of models in production simultaneously. And across all of this, we need to manage the governance, the explainability, the maintainability and traceability of all of these components. So what we really need to be able to do is deploy our models and their associated services as connected sets of data. So what I want to do now is show you how you can do that using the new Jenkins-X machine learning Quickstarts. To create a new machine learning project, just enter JX create ML Quickstart. Name the repository, and then if you select the top entry of a given type, that will automatically create both a training and a service project. So that's done, and you can now see we have two projects created, one for our training environment and this one for our service. But note we have no model in here at the moment. So the builds for these will kick off simultaneously. And you can monitor the output of those. So the training project is just running now. It's just training a simple model which is persisting, and then it will create a pull request on the service repository to include that trained model within that repository. Now it's going to go ahead and complete the builds for both those projects, but only one pod will be created, and that will be the one for the service repository. And you can see that's been created in staging environment, but it's throwing an error because at the moment it doesn't have a model that it can load and run against. But since we've already created a pull request, it will now go ahead and create a preview environment with another instance of that service which does have the model associated with it. And that's now running. So we can go and test that. First we just need to put a port forward in place so that we can connect to the service. And then if we just go to localhost, we'll be able to see the output of that trained model. And this could be any type of service. So if we then go back and look at our service project, you can see the pull request. And now we have a trained model which is embedded in that project code base. So if we look at the pull request conversation, we can check and review that in the normal way. And then when we're happy with what we've got, we can sign it off, and that will cause the project to be automatically rebuilt and deployed into staging with the trained model associated. You see the builder's kicked off again, and you can see our existing instance of the model in staging is still not operating, but we're now building a new version which is being redeployed, and that's now running successfully with its trained model. So hopefully that was useful. Thanks for watching, and see you next time.